Hi guys, so before I start, let me know two things that you can hear and see me clearly, and you can also see the iPad screen. So we will begin at in 2 minutes. Let's begin at 6:10. Okay guys, how is everyone? Is there some problem because in the last class there were a lot many people. Today there are only 8. Okay, no problem. Let's begin. We have waited enough. We are not going to wait anymore. So today is the last session for this NSET preparation, last bootcamp. So I have okay, Moksha. We are not going to code actually nothing because in your NSET exam you are not supposed to code anything. Some people are unable to join. Is that a problem? So let me raise this point to Saloni. All right, I have raised the issue, but we will not be waiting for anyone. We cannot wait anymore. Let's start. So I have selected. No, Mox, there is no. I'm sure there are no coding questions. In mathematics questions, do you want to use coding? Up to you. If you want to, that is fine. All right. So I have selected 7 questions for today, of different kinds. All right. So the first 2 are logical questions, logical math questions, cat-like questions. But I would want to show you those also. The next 2 belong to puzzles. The next is I wanted to show you a graph problem from Learnability. So we would do one of that. And next 2 are DP problems. So how I propose is, let us do one from each section, and if time is left, we would try to do one more also. All right. So let me start from the logical group. Okay. So this first question I have picked from a popular cat website. So I'm throwing the question to you. Let me know whether you can solve it or not. Okay. So the fact that is given to us is that if xy plus yz, if xy plus yz is odd, which of the following statements is false? Which of these 4 is false? A, B, C, D. First one is xy plus yz plus xz is odd. Is this necessarily false? Next is x plus yz is odd. Next is yz plus xz is even. Next is x raised to power y into y raised to power z into z raised to power x is odd. So this is a question, a normal number theory question based on odd numbers, even numbers. So this is a question that is thrown to you. If xy plus yz is odd, which one of these do you think is false? So only one of them is false. Which one do you think is false? Kunal, I have just started. Just started. This is the first question that I have thrown. So I have just told people that I have 4 groups for today. One is logical problems, one is puzzles, one is Dijkstra from graph, that is learnability, and 2 problems for DP. 7 problems in all. So I will try to cover at least 4, one from each group, at least 4. Mike, I have just joined. I have also just joined. I did not start before 6:10. So I have just started. This is the first question that I have thrown. This is the first question. If xy plus yz is odd, which one of these statements is false? Xy plus yz is odd. So which one is false? Over to you. You have to think. A normal number theory question, basically. Cat kind of a question. I am waiting for your answer, basically. So right now it is your turn to solve. I will solve after 2-3 minutes. No, Madhu Kiran, that is not the answer. And please send your answer privately. Do not send your answers publicly. I would want the other people to solve it also. Aman, this is the question. If xy plus yz is odd, x and y and z are natural numbers. Xy plus yz is odd. So we have to tell which of these situations, which one of these statements is false. Which one is false? Nakul and Aman, is the question clear? Yes, ma'am, true. Nakul and Aman, is the question clear? Please send your answer privately. Mayank, your answer is correct. Madhu Kiran, your answer is still wrong. Moksha, the answer is correct. Lokita, the answer is wrong. Should I wait 2-3 minutes or should I help you solve it? Wait, okay. All right. No problem, Sakshi. So this is what the question is. If xy plus yz is odd, okay, I have to tell which one of these statements is false. X and y and z are natural numbers. The answer is D. Let us see why. Okay. So I'll be solving now. We have like 7 questions. Let's see. At least we should do 4. So I will have to move. Okay, Kunal. All right. So see, xy plus yz is odd. All right. X into y plus z is odd also. Of course, I've just taken x common. Now, what does that tell me about x and y plus z? Let's just think. What is the answer of odd into odd? If odd is multiplied by odd, what do I get? If 2 odd numbers are multiplied, what do I get? You will have to participate, no? Odd. What is the product of odd and even? What is the product of odd and even? Even. What is the product of even and odd? Even. What is the product of even and even? Even. So, if x into y plus z is odd, what does these 4 statements tell you? Sorry, the common was y. I'm sorry. Xy plus yz was no? Oh, okay. All right. So that is fine. No problem. So actually, slightly my question was wrong. The input that was given was xy plus xz is odd. Okay. So maybe some of you would have solved it correctly. So x is common and y plus z is the other factor. 2 factors are x into y plus z. So what does that tell me? If this product is odd and if this is odd, does it imply that x is odd and y plus z is also odd? Do you agree with the statement that yes, x and y plus z are odd. Do you agree? Cool. So we know that x is odd and we know that y plus z is odd. Cool. So x is odd. Between y and z, we do not know whether they are odd or even, but we know that y plus z is odd. Now let us focus on one more thing. If y plus z is odd, what does that imply? What do you think? Odd plus odd is equal to what? An odd or an even? My question to you. Odd plus odd is an odd or an even? Even. Odd plus even is? Odd plus even is? Odd. Even plus odd is? Odd. Even plus even is? Even. So these two statements tell us that when you have one odd number and one even number, you get an odd. If both are odd, you get an even. If both are even, you get an even. So what does that tell us about y and z? That tells us one of them. That tells us one of the two things. Y is odd and z is even. Or y is even and z is odd. Is this true? Is this true that either of the two things are true? Either of the two things are true. Certainly x is odd. Certainly x is odd. Y is odd. Then z is even. So we know x is odd. If y is odd, then z is even. Or we certainly know, about x we know that x is odd. If y is even, then z is odd. So one of the two situations is correct. Does this make sense? Why? Because we knew x into y plus z is odd. So we knew x is odd. That was a guarantee. And we knew y plus z is odd. Y plus z is odd implies if y is odd, then z is even. If y is even, then z is odd. So are we aligned on these two situations that yes, one of these two situations is true? So what I want to say is, I will write it like this. X is odd. If y is odd, then z is even. Or x is certainly odd. If y is even, z is odd. Okay. Alright. Now with these two statements, but y has to be odd cause zy. No, Srinidhi, the only given thing to us was that xy plus yz is odd. We had to check whether these statements were true or false. We had to check which one of these statements is false. Okay. So now let us evaluate. The first statement says xy plus yz plus xz is odd. We have to tell whether it is false or true. So let us evaluate. Xy plus yz plus xz. A. Statement A. According to these two. Xy plus yz plus xz. Okay. We know, let us use the first statement to evaluate it. So let us call it statement 1. Let us call it statement 2. According to statement 1. X is odd, y is odd, z is even. So x dot y dot z, x dot z. So x is odd, y is odd. Odd into even, odd into even. So odd into odd is odd, odd into even is even, odd into even is even. Two evens and one odd is equal to, so sum of two evens is basically an even, and odd plus even is odd. So this says xy plus yz is odd. And what did the statement say? Statement was also saying that this is odd, which means it is not false. At least according to statement number 1. According to statement number 1, it is not false. Okay. So we need not check for statement number 2. If it was false for both 1 and 2, then it would be false. Alright. So A is not our answer. Let us go to situation B. What does situation B say? Xy plus yz is odd. Easy. Let's see. Xy plus yz is odd. It's saying a simple thing. Xy plus yz is odd. No problem. 1, using 1, which is odd into even plus even into odd. So odd into even is even into odd is even. According to statement number 1, this is false. Now let us use statement number 2. Statement number 2 was this thing. X is odd, y is even, z is odd. Okay. Actually this was 2. Now I would use 1. So x into y is odd into odd, and y into z is odd into even. Okay. So this becomes odd, this becomes even, which gives me odd plus even is odd. So xy plus yz is odd. Xy plus yz is odd. So according to one statement, according to one of the situations, this is false, but according to the other situation, this is true. If it would be false for both 1 and 2, then it is false. Otherwise, it is not false. It has to be false for both of them. Okay. So this also passes. B is not false, not for all the numbers. C. So C is what? YZ plus XZ is even. YZ plus XZ is even. Similar thing. If it has to be false, it has to be false for both the situations that we have. So our statement number 1 says X odd, Y odd, Z even. And statement number 2 says X odd, Y even, Z odd. So let us evaluate for both of them. YZ, according to this, odd into even. XZ, odd into even. So this is even plus even equal to even. So for the first statement, this is not false. It has to be false for both of them. It is not false for the first statement. I am not going to test for the second statement. Calculator allowed? Of course, you can use calculator, I think. Nobody is testing that. The last part. This says it is odd. Let's see whether that is odd or not. X raised to power y raised to power z, z raised to power x. D. X raised to power y raised to power z, I think z raised to power x is odd. That is what the claim is. Our statement number 1 said x odd, y odd, z even. And statement number 2 said x odd, y even, z odd. We have to evaluate whether this is false for both of them. If it is false for both of them, then this is going to be our answer. Let's see. According to this, odd raised to power odd into y is odd, z is even, which means odd raised to power even. And the last part is even raised to power odd. Even raised to power odd. What do you think? If any odd is raised any number of times, I think it stays odd only. If you multiply an odd any number of times, it stays odd. Even if it is raised even number of times, even then it stays odd. And if any power of even is always even. Odd into odd is odd, and odd into even is even. So this is false. This is false for statement number 1. So x raised per y into y raised per z into z raised per x is actually even for this statement. Let us evaluate for the other one also. If it is true, if it is false for that also, if it is false for both the situations, then it is necessarily false. Let us see. So this says odd, even, odd. Okay. So odd raised to power even raised to power odd, and finally odd raised to power odd. So this is odd, this is even, this is odd. Odd into even is even, even into odd is even. So this is even for even this. So this statement is even. X raised to power y into y raised to power z into z raised to power x is actually even, no matter whether we choose if y is odd and z is even, or if we choose y is even and z is odd. So regardless of the situation, x raised to power y raised to power z into z raised to power x is always even. It can't be odd. So this situation is false. I hope you got a type here. You understood that it is actually a logical question only. You have to figure out powers and multiplication and how odd and even behave in addition, division, multiplication and powers. So I will call it a mathematical aptitude kind of a question. Which topic does it belong to? Number theory. Number theory has real numbers, odd numbers, even numbers, that kind of stuff. Okay. Let us do one more question of similar kind. This question would belong to prime numbers. So let's see whether you would be able to figure it out or not. Okay. So you are given question. You are given a number 1999. All right, 1999. And P plus Q equal to 1999. Just let me have, I have a resource. I will have to check that resource for the exact. So P plus Q equal to 1999. P and Q are prime. P and Q are prime numbers. Prime numbers. You have to tell me what is P into Q. What is P into Q? Over to you. So you have 2-3 minutes, 4-5 minutes to solve it. I think the question is easy. You are given 1999 P plus Q equal to 1999. P and Q are prime numbers. What is the value of P into Q? Think about the properties of prime numbers and use that to solve this question. Think about the properties of prime numbers. That would help you a lot. So I will hide my face for 2-3 minutes so that you can focus on the question. Solve till 6:32, 4 minutes, I think more than enough. After that, I'd help you solve it. No problem, Swam, no problem. This is the question that everyone is solving. So this is only the second question that I am solving. So there are two numbers, P and Q. P plus Q equal to 1999. Where P and Q are prime. You have to tell me what is the product of P and Q. So I have two answers from Aman and Ananya. Both answers are correct. Mayank, correct. Correct. Shubh, incorrect. Ashutosh, incorrect. 7 plus 11 is not 1999, no? Arush, correct. Alright, let's solve it. Let's solve it together. See, P plus Q is 1999. Okay? And it is told that P and Q are prime. Okay, Srinidhi, I'll wait for 1 more minute. I'll wait 40 seconds more. Gurudat, correct. So let's wait for 40 more seconds. Solve as many people as you can solve by then is great. So keep on solving, and after 30 seconds I would solve. Everyone is giving correct answers. Sakshi, Abir, correct answer. Gurudat, correct answer. Sheikh, correct answer. Balaji, correct answer. Alright. Now I think it's my time to solve it. Okay? Correct answer, Sakshi. See, P and Q, the sum is 1999. They are prime. But this number is odd, which implies either one of them has to be odd. So either P is odd and Q is even, or P is even and Q is odd. Alright, regardless. So we know that one of them is odd. One of them is odd. Okay. Now tell me, are there any even prime numbers? We have just realized that one of them is odd. One of them is odd. And one of them is even. One of them is even basically. And one of them is odd. One of them is odd. Now tell me, are there any even prime numbers? Even numbers can't be prime numbers because they get divided by 2. But what about 2 itself? 2 is the only even prime number. When I say that even numbers can't be prime numbers because they will get divided by 2, that is true. So even numbers can't be prime numbers. What about 2? 2 is a prime number because it gets divided by only 1 and 2. In fact, 2 is the smallest prime number and 2 is the only even prime number. 2 is the only even prime number. So a slight trick in the question actually. So 2 is the only even prime number. Okay, if 2 is the only even prime number and one of them is even, so one of them is 2. So let us say P equal to 2, then Q is equal to 1997. In that case, P into Q is 2 into 1997. That is whatever that was. Why one is even and one is odd? Swam, see no? Because 1999 is odd. 1999 is odd, and if the sum of two numbers is odd, one of the numbers has to be even and the other one has to be odd. Isn't it correct, Swam? See, even plus even is always even. Even plus odd is always odd. Odd plus even is always odd. Odd plus odd is also even. So, if the sum of two numbers is odd, one of the numbers has to be even and the other number has to be odd. Is it correct? Swam, is it correct that if the sum is odd, one of the numbers has to be odd and the other number has to be even? And they were also prime. So, which is the only even prime number? That is 2. So, which means one of the number is 2, the other number is 1997. The product is, so whatever the product is, I think 3994. Has everyone understood it? Did you guys understand this? I think it was an easy question. Slightly tricky, but I think if everyone of you was given 15 to 20 minutes to solve this question, I think everyone would have solved it if given 15 to 20 minutes. So slightly kind of a practice thing. If you are in the touch of such stuff, you would be able to solve it. If you are not in touch, then they would be slightly difficult. But logical problems nonetheless. Okay. Now I move to my second group of the day, which is puzzles. Okay. So these puzzles have programming in the background. So at the heart of them, they are programming questions looking like maths questions. Well, let me show you one and let's see whether you would be able to figure it out or not. Okay. Is everyone familiar with the concept of logarithm? So that's only one question. Does everyone know that logarithm 32 to the base 32 is what? Do you guys know? Log 32 to the base 2 is what? What is that answer? No, it is not 8. It is 5. It is 5. So basically it is the reverse of power. It's the reverse of power. So if 2 raised by 5 is 32, it means log 32 to the base 2 is 5. It is the inverse of power. Okay, inverse of power basically. Alright, and it is wherever powers are involved, logarithm is always involved. So because binary number system has as base of 2 and every number system is based on powers in the sense that the place values are powers of that base. So logarithm is going to be involved there. So this is a puzzle. Hear it out and see whether you can solve it. Rats and poison. Now do not go to Google and try to find the answer of it. Okay. So what is the situation? Let us say you have 8 bottles of wine or juice. The source had wine, but let us say there are students. So let us say we have 8 bottles of juice. Okay. Unfortunately, one of the bottles got poisoned. One of the bottle is poisoned. The poison needs 1 hour to show its effect. Okay. Now you had a rat trap and you caught you have infinite supply of rats available. So you had caught many rats. Infinite supply of live rats is available. Infinite supply of live rats is available. We had a rat trap and we caught many rats. Okay. So now what we want to do is we want to know which one of the bottles is poisoned so that the rest of the bottles we can drink ourselves. So we can use these rats. There are infinite supply of rats available. We can use these rats to find out which of the bottle is poisoned. So let me tell you one stupid way. Okay, I will pick 8 rats. Each rat would drink from one bottle. So I will see which rat died. So if one of the rats die and the rest of the rats live, then I would know which bottle has the poison. Is this strategy clear? That of course, if you would pick 8 rats and each of the rat is assigned to each of the bottle, so after 1 hour, one of the rats would die, 7 of the rats would live. So I would know which bottle has the poison. Okay. But this is a very cruel strategy. This is a very cruel strategy. I killed 8 rats. I killed 8 rats for a job that did not require killing 8 rats. So you have to devise a strategy. No, this is not fine. So this is fine for 8 bottles of juice. What if we have 1,000 bottles of juice? Will we kill 1,000 rats? So it is not fine because it is wastage of resources. So if you think it in the terms of rat, it is okay. But if you think it in the terms of computer science, and if you think it as a problem of optimization, rats were our resources. Rats were our resources. They were our kind of a poison testing sample. So we are wasting resources. We have to optimize the use of resources. We cannot use all our resources if the work can be done in lesser resources. So your job is what? Figure out minimum number of rats required to find out the poisonous bottle within 1 hour. So if I would increase the time, even 1 rat is enough. So think about this. If I would increase the time, even 1 rat is enough. So I'll pick 1 rat, assign him to bottle number 1, drinks from there. If he's alive after 1 hour, okay, this did not have poison. Now assign him to bottle 2. If he's alive after 2nd hour, this did not have poison, and so on and so forth. Okay. So if the time is infinite, 1 rat is enough. If time is only 1 hour and I am not trying to optimize resources, I will use 8 rats and find out. But now I want to optimize time and resources both. You have to find out within 1 hour only. So figure out the minimum number of rats required to find out the poisonous bottle within 1 hour only. Within 1 hour. So time is still dear to us. Just like a computer science problem, we have to save time and memory both. Because time and memory are both costly resources. So you have only 1 hour and you still have to find out the poisonous bottle. How many rats are required? No, of course not 7. Of course not 7. No, not 4. Waiting. I just got a correct answer. Yes, Aman Pandit. Prakhar also has the correct answer. The correct answer is 3. So I want you to figure out why 3. So let me just tell you the answers and then you have to figure it out. See. Please listen to me carefully. If the number of bottles is 5 to 8 bottles, 3 rats are enough. For 9 to 16 bottles, 4 rats are enough. For 17 to 32 bottles, 5 rats are enough. So on and so forth. For 33 to 64 bottles, 6 rats are enough. I think 3 to 4 bottles. For 3 to 4 bottles, 2 rats are enough. Okay. So you have to figure out why is this logic working like that. Yes, I'm correct, but do not write it publicly. No, do not write it publicly. Everyone knows it. Okay, so I have shown you this pattern. You know the question. The question was 8 bottles of juice. One of the bottle is poisoned. The poison needs 1 hour to show its effect. Infinite supply of live rats available. We have to figure out minimum number of rats required to find out the poisonous bottle within 1 hour. So 2 important parts of it. We still have to find out our answer in 1 hour, and number of rats required has to be minimized. There are two important parts of the problem. I have already told you the answer here, that 33 to 64 bottles would require 6 rats. And actually, if you would want to focus, only focus on these numbers. Only focus on these numbers. 4 bottles require 2 rats, 8 bottles require 3 rats, 16 bottles require 4 rats, 32 bottles require 5 rats, 64 bottles require 6 rats. What is happening? What is happening? Okay, so focus on this. Focus on these two numbers. 4, 2, 8, 3, 16, 4, 32, 5, 64, 6. Why? Why is it working like that? So, again, this is 6:43. 6:43. Take time till 6:47. 3 minutes, 4 minutes. 3 minutes is enough actually. So 6:46. Take 3 minutes. Try to think, what could be the strategy? Why is it happening like that? Why log of something to the base 2? Why? Why is it inverse of power of 2? Why? Alright? Hint, try to express these numbers in binary. You would get something. But over to you for 3 minutes. Try to think of a strategy. Then we'll talk. Then I'll solve the problem for you. Okay, so pay attention, I will tell you the algorithm. That is what the trick is, Swam. So listen to it carefully now. Please, I need your attention because I'll try to solve it and I would need your attention. Otherwise, I will have to repeat it 3-4 times. Okay, because someone would ask that out again and again, then I will have to explain many number of times. Let us do it for 8 bottles. 8 bottles. So what I would do is, for 8 bottles, I will write all the binary numbers before the binary of 8. So I will write the first 8 binary numbers starting from 0. So 0th binary number, this is the 0, 0, 0, 1, 0, 1, 0. Is everyone familiar with the binary counting? Is everyone familiar with the binary counting? Okay. All right. So to express 8 different binary representations, how many places, how many digits do I need? How many bits do I need? My first question to you, to express 8 distinct binary numbers, how many bits do you need? How many bits are required? Basically 3. Why 3? Because 3 places, every place can have 2 values, that is 0 or 1, 0 or 1, 0 or 1. So 2 into 2 into 2 is 8. Is this clear to everyone that to express 8 distinct binary numbers, only 3 places are required. Only 3 bits are required. I will not say digits, I will say bits. Is this fact clear to everyone? Of course. All right. Great. So if I had 8 bottles, so in binary, in decimal, those bottles would be like, they would be numbered like bottle number 1, bottle number 2, bottle number 3, bottle number 4, bottle number 5, bottle number 6, bottle number 7, and bottle number 8. That is what the numbers of the bottles would be. Or I can also say the number of the bottles would be bottle 0, bottle 1, bottle 2, bottle 3, bottle 4, bottle 5, bottle 6, bottle 7. But the person who was labeling these bottles was a computer scientist, and he used to count in binary. So he labeled the bottles like bottle 000, bottle 001, bottle 010, bottle 011, bottle 100, bottle 101, bottle 110, bottle 111. Okay? Is it using in search? Aman Pandit, yes. So I'm going to use a concept of a very weird way of binary search, and yes, this helps in search optimization. This helps in search optimization. Binary search is the most commonly used binary search algorithm. So search algorithm. Okay. All right. Come back. Are you guys aligned that yes, this is a fine way of labeling these bottles? I could have labeled like them like this, because bottle number 1, bottle number 2, this is of course natural. I could have labeled the bottles like this. If I could label the bottles like this, I can certainly label the bottles like this also, starting the counting from 0. Bottle 0, bottle 1, bottle 2, bottle 3, bottle 4, bottle 5, bottle 6, bottle 7. And if that is okay, in that case, I can label the bottles in binary also. Bottle number 000, bottle number 001, bottle number 010, 001, 011, 100, 101, 110, 111. So this is bottle, not bottle 7. This is bottle 111. Okay. Now the 8 bottles are B000, B001, B010, B011, B100, and do not call them 4, 5. Call them this only. These are the bottle numbers. This is bottle 110. This is bottle 111. These are my 8 bottles. My 8 bottles. Okay. Now, on each bit, one rat is sitting. So see what I am going to do, and listen very carefully. Pay close attention. Rat number 1, rat number 2, rat number 3. Okay. So rat number 1 would be made to drink from this bottle, this bottle, this bottle, and this bottle. So rat number on the 0th hour itself, he will not drink from this bottle, not from this, not from this, not from this, but yes from this, yes from this, yes from this, and yes from this. Rat number 2 would not drink from this, but will drink from this, and this. He would drink from 4 bottles. Each rat would be assigned to 4 bottles. Each rat is assigned to 4 bottles. Would not drink from this, but would drink from this. Not from this, from this. Not from this, from this. Not from this, from this. Now, I told you, did you understand how the rats are drinking? From which bottles are they drinking? Rat 1 is drinking from these bottles. Rat 2 is drinking from these bottles. Rat 3 is drinking from these bottles. Wherever the 1 is. Okay? He is drinking from those bottles. Now, after 1 hour, what if I tell you? What if 1 bottle has poison? Aman, I am going there. If after 1 hour I tell you this rat is dead. In fact, if I tell you all 3 died. What do you think? Which bottle has the poison? If all 3 died, what do you think? Which bottle has the poison? If all 3 died, which is the only bottle from which all 3 drank? So what you have to see is this 0 and 1 represents, has the rat drunk from that bottle or not? 0 represents I would not drink from it. 1 represents I will drink from it. So rat number 1 has not drunk from these, but has drunk from these. Rat 2 has not drunk from these, but has drunk from these. Rat 3 has not drunk from these, has drunk from these. So these 1 and 0 represent from which bottles are the rats drinking. Okay. Now I am telling you all 3 rats died. All 3 rats died. What does that mean? Which bottle has the poison? If all 3 rats died. Bottle number 8 or bottle 111. The last bottle. Why? That is the only bottle from which every rat has drunk. Okay. So see. I would help you deduce that answer also. Keep paying attention. This rat is dead. means poison is at least in one of these 4 bottles. Is this clear? If this rat is dead, implies poison is in one of these 4 bottles, because he had drunk from these 4 bottles. Do you agree that the death of this rat implies poison is in one of these 4 bottles? One of these 4 bottles, basically. Agreed? Okay. Rat number 2 also died. Implies out of these, the poison is actually in these 2. Because he is also dead. Out of these 4, rat number 2 drank from only these 2. Which means now our problem space is halved. We know that the bottle is among these 2. And the last rat is also dead. Which tells me out of these 2, he did not drink from that and drank from that. And if he is also dead, it implies poison is only in this one. Okay, let me again do it. And keep paying attention. What if I tell you alive, dead, alive. Alive, dead, alive. Alive, dead, alive. What does that mean? Okay, let's see. So this rat is alive. Alive means by confidence we know that these 4 bottles are non-poisonous. Because he has drunk from these 4 and he has survived. These bottles are non-poisonous, which means these 4 are poisonous. Is this clear? That his staying alive has told me something. His staying alive tells me that these 4 does not have poison. These 4 have poison. Do you agree? Say yes if you agree with this statement, that his staying alive has told me something. His staying alive has told me these are non-poisonous, which means one of these is poisonous. We know for guarantee all 4 of these are non-poisonous, because this guy has drunk from all 4 and he is still alive. So poison is not in this space. So poison is in this space. We are actually trying to minimize the space, minimize our doubt on bottles. So see, if you were a police guy, forget all this. If you were a policeman and you thought there were 8 criminals, but by asking one question, you know that 4 of them are non-criminals. Now your solution space, your problem space is minimized. Instead of worrying about 8 criminals, now you have to worry about 4 criminals. If the second answer of second question tells you that out of these 4, 2 are non-criminals and 2 are non-criminals, your problem space is again minimized. You are trying to minimize your problem space. Initially, I had a doubt. Before this answer, I had a doubt on all 8 bottles. All could be poisonous. I do not know which out of these 8 is doubtful or poisonous. By taking a look at this answer, that this rat is alive, I know now that these 4 are non-poisonous. So my doubt is only on top 4. Top 4 now. One of these is poisonous because these are non-poisonous, because the rat who drank from these 4 is alive. Okay. Now you see a dead hair. And we are only finding in the first 4 bottles. This guy is dead. Out of the first 4, from which one he did not drink from these, but he drank from these, which means the poison is in these 2 bottles, one of these 2 bottles. Do you agree that yes, him being dead tells us, we were worrying about this space, him being dead tells us he did not drink from these, he drank from these, means poison is in one of these 2. And the last one is again alive. Now we are worrying only about these 2 bottles, and the last one is alive. He did not drink from this, he drank from this. He drank from this and he is still alive, implies this one is non-poisonous, implies this one is poisonous. This one is poisonous. Do you guys agree that yes, bottle 010 or the third bottle is the bottle which has the poison? Say yes if you agree with this. Correct? So if I had 16 bottles, okay, if I had 16 bottles, so to represent, now my question to you, to represent 16 binary numbers, how many bits do you need? To represent 16 binary numbers, how many bits do you need? 4. So 0000, 0010, 0011. So, sorry, I mean, now you can do it. I am not going to do it. But I hope everyone realizes this, that for 16 bottles, because for 16 bottles, 4 bits are enough, and for 16 bottles, 4 rats will be enough. Is the algorithm clear or not? If the algorithm is not clear, let me know. I will explain it again. If it is clear, say that it is clear, I would move forward. Did you enjoy the question? Did you enjoy the question? So what I am saying is, now forget about this question. Forget about this question. See one thing. See one thing very, pay close attention to it. So this was actually a question on binary number system. This was a question on binary number system. Does this question need prior knowledge of programming? I will say no. This needs prior knowledge of binary number system and logic. So this is a puzzle, this is a maths question, but this is not a programming question per se. This is also a programming question. If you have done some programming, it would become more natural for you to think. But otherwise, Ashutosh is saying that I have to explain again. I can explain again, no problems. I'll quickly explain again. How can we predict which question contains binary? So if, how to predict that? Yes and no would be there. Yes and no would be there. Okay. But then it would not click unless you've already done it before. Oh man, can be argued both ways. So do you want to say that nobody in the world is smart enough to figure it out on the first attempt themselves? I will say no, that is not true. I do not claim that I am that person. I am not that person. I am a person, if he has been trained, then can solve it. But there exist people who are naturally good with such stuff. And we are actually trying to find out people who are naturally good with maths. Okay? In this question, actually, there was no yes or no. Okay. Let's come back. I am missing. Of course, Mancha, if there are 32 bottles, 5 rats would be enough. Because for 32 binary numbers, you need 5 bits. Because 2 raised by 5 is 32. Okay. So the answer, if you want to have answer in one formula, the formula is log of bottles to the base 2 seal. I hope everyone knows what a seal is. So what is the seal of 3.4? Tell me what is the seal. What is the seal of 3.4? Seal is the next largest number. Seal of 3.4 is 4. Seal of 3.6 is 4. And floor is 3. Floor and seal, the concept of floor and seal. Floor is the upward next integer. Seal is the downward next integer. Okay. Correct. All right. I would want to move forward. Is there anyone who wants me to explain this question again? Because I can do. I had one person who was asking for it. I do not know which one was that. Do you want me to explain it again? I can. Or do you want me to move forward? So let's move forward. All right. Okay. So you have seen some maths from 2 groups now. There was odd even, there was prime number. I have told you a binary number system question. Greedy pirates is a recursion question. I would come back to that. Let me teach you the Dijkstra algorithm from learnability. Now this is not the maths part. This is the learnability part. I will teach you Dijkstra algorithm of graphs. Okay. And after teaching Dijkstra problem, then I would show you a similar graph and ask the answer from you. Okay. So this would help me know that are you guys able to learn dry run of an algorithm. Okay. So see, what is going to happen for the next 15-20 minutes is I am going to teach you something. So this is not the math section now. This is the learnability section now. I am going to teach you something new. Something called a Dijkstra algorithm. This J is pronounced as her. The Dijkstra algorithm. This is a graph problem. Okay. So let us say, forget about graph. I would call them roads and bus stations. Okay. So here is a city A, B, C, D. City number E, F, and G. These are the cities. These cities are, no, Kunal, Dijkstra is neither DFS nor BFS. It is priority based BFS. So priority BFS. I will call it priority BFS. Okay, not regular BFS DFS, it is priority BFS. So now listen to it. Listen to it. A, B, C, D, E, F, G are the cities. They are connected via roads. And let us say the road from A to B is 10 kilometer. From B to C, 10. C to D, 10. A to D is 40. D to E is 2. E to F is 3. F to G is 3. E to G is 8. Okay. What does this problem solve? You are given a starting point. You are given this graph, which is cities and the roads, and you are given a starting point. Starting point, for example, A. And you have to tell me, yes, this is a weighted graph, and you are told a starting point A. You have to tell what is the shortest path from A to all of these. Shortest path from A to all of the other vertices. I think this nomenclature is pretty standard. Vertices, these are the vertices. The rest of them are edges. Okay. No, this is not Kosa Raju. That is different. So this is the extra. Okay. So we have to tell, our answer would be what? Our answer would be what? Our answer would have A, B, C, D, E, F, G. Our answer would have 7 entries. And against every station, there will be 2 things, a path and total distance. Total distance. Path and total distance. Is the question clear? Is the question clear? So what are we trying to solve? What are we given as input? We are given input in the form of this graph. These are cities. Okay. And these edges, vertices and edges. So these edges are roads with distance 10, 10, 10, 40, 2, 3, 3, 8. Yes, Sakshi, I am repeating the question. Please listen carefully now. What are we given? And what is expected out of that? That is what the question is basically. So the first thing that is given to us is this graph. A graph is a set of connected vertices and edges. But do not worry about that. A graph is this diagram. Just think like a graph is this diagram. These are the cities. Okay. And these cities are connected via roads. And this is the distance on those roads. Okay. Now do not be too formulaic. Instead, so this is the first input. Now the second input. This is the first input. Second input is starting point. You are told a starting point. That is A. Now what is expected? Expected output. Expected output. Expected output is a table. Basically a table. Where you are telling from A to each one of them. A to each one of them. What is the shortest path? Shortest path. Shortest path. And distance on the shortest path. For example, from A to A, the shortest path is A and distance is 0. From A to B, the shortest path is AB and the distance is 10. From A to C, the shortest path is ABC, the distance is 20. From A to D, the shortest path is not AD, it is ABCD and the distance is 30. From A to E, the shortest path is ABCDE, the distance is 32. From A to F, the shortest path is ABCDEF, the distance is 35. From A to G, the shortest path is ABCDEFG, the distance is 38. Now my question that I have to ask is, no, this is not a minimum spanning tree, that is a different question. Minimum spanning tree is also an interesting question, Gurudat, but this is not that one. Okay, so is the input and the output clear? How many inputs are there? There are 2 inputs. First input is this graph, second input is the starting point, and the expected output is this table. This table has 3 columns: vertices, shortest path, and distance. Distance from A or from starting point, from A. Is the input and output clear? Because I will now start teaching the algorithm. And after I have taught you the algorithm, Raj Ratan, total distance is not required. Just focus on the input and output. No, this is the expected output. This table is the expected output. Now I will start teaching the algorithm. Learnability means you have to focus on the algorithm now. Understand the algorithm. You now know the input and the output. Understand the algorithm. After I have taught you the algorithm, I would give you a similar graph and a starting point in that graph, and I would ask you the same question. Let's see whether you would be able to solve that or not. You would have to give me the output of the table of that graph. Okay, So let's focus on the algorithm now. How does this work? All right. A, B, C, D, E, F, G. 10, 10, 10, 40, 2, 3, 3, 8. Starting point equal to A. All right. So I start with a tree, kind of a tree. And in that tree, I enter my starting point. This, whatever I am entering in this tree, in node of this tree, 3 pieces of information. First piece of information is vertex. Where am I? Path to that vertex. And cost or distance. So what are the 3 things that I am adding in a node? What are the 3 things that I am adding in a node? 3 things that I am adding to the node are vertex, path to the vertex, and distance so far. Is this clear? That I am adding 3 things. So I am starting from the starting point. Vertex is A, path is A, and cost is 0. Now remember the algorithm. Very simple algorithm. Basically, algorithm has these parts only. Remove. First part is remove. Second is mark, star, mark. Third is work. Fourth is add neighbor star. Remove, mark, work, add neighbor. So right now what you should do is write this on a pen and paper. This is the algorithm. R, M star, W, N star. Remove, mark star, work, add neighbor star. Write this thing on a piece of paper. Remove, mark, work, neighbor. Why is there a star? I would explain that. Okay. I hope the algorithm is with you now. So this is the algorithm. Remove, mark, work, add neighbor. For add neighbor, I would write N star. Okay. So Kunal, I will show you what this is. I'm going to repeat it many times over. Remove, mark, work, neighbor. So let me start with the algorithm now. See, remove. I have removed from the tree. I have removed this node from the tree. Mark on the graph. We removed A, that is why A is marked. Star, what star means, I will let you know. Work is add it to the output table. So to the output table, I will enter my first entry. Vertex, path, distance. So A via path A at a distance of 0. This is work. So remove, this was remove, mark was this, work is adding to the output. Neighbors of A are B and D. Add that to the tree. So see, I am adding B and D. But a node has 3 pieces of information. So B is added here. Path to B will be the old path plus the vertex name. The cost would be old cost plus this edge that you have taken, 10. And for D, see what is happening for D. Old path plus D, AD. Old cost plus this edge, 40. Is this part clear? Okay. Now Kunal says no. No problem, Kunal. I would do it twice. So let me proceed a little and then I would come back and then this would become clear. From this tree, when you remove, you have to remove the person with the smallest value, smallest path. So you can't remove D, you have to remove B first because that is the shortest path. So see again, I am going to do these 4 and see how these 4 are working. Remove, this is remove. Mark, B is marked. Work, add this to the output table. B via AB at the cost of 10. Neighbors of B. Why does neighbor have a star? B has 2 neighbors. We have 2 neighbors, A and C. But you add only the unmarked neighbors to the tree. So A is marked. I will not add that. C is unmarked, so I will add C here. And now see carefully. C. Old path is AB plus C. The path is ABC. Old cost is 10. This edge is also 10. 10 plus 10 is 20. Is this algorithm clear? Now let me repeat it. Now let me redo it so that this might become clear to you. A, B, C, D, E, F, G. You have to participate and you would have to give me answers where asked. 3, 3, 8. Do you connect C and D here? Srinidhi, we would do it, no? So first things first. There is a starting point of A. First thing first. The first node that I add here, the first node that I add in the tree has 3 pieces of information. What are the 3 pieces of information that we add? What are the 3 pieces of information? The first is vertex, second is path, third is cost or distance. So remember, vertex, path, distance is what the tree node contains. Okay, vertex, path and distance. Actually, that is our output format also, vertex, path and distance. The algorithm is remove, mark star, work, neighbor star. So I'll add AA0. Vertex is A, the path so far is A, okay, and the cost is 0. AA0. Let's start with the algorithm. Removed. Mark. Here's the mark. Work. So output, whatever, let's say I'm writing the output here. AA0. Vertex, path, cost. Output. Work is done. Now neighbors. Neighbors of A. Now tell me what are the neighbors of A in this picture. In this diagram, what are the neighbors of A? Who are the neighbors of A? Who are the neighbors of A? B and D. Alright. Add the neighbors to the tree. So see, B and D will be added here. B and D will be added here. Now see how I add it. Vertex B and D are added, but the path to B, the old path, the path till A plus B. The cost till A plus the cost from A to B. D would be AD and 0 was the cost till A. Now you are using 40, so 40. 0 plus 40. Now let's repeat it. Which one do I remove now? What did I tell you about removal? Removal is on the basis of cost or distance. Lesser distance gets removed first. So BAB10 gets removed. Mark it. Done. Work. BAB10. Add neighbors. Now B's neighbors would be added. Who are B's neighbors? Now tell me from this diagram, who are B's neighbors? Who are B's neighbors? Of course, I'm not sure whether the graph will be to scale or not. Who are B's neighbors? A and C. No, B's neighbors are not A and B. B's neighbors are A and C. But neighbor is actually neighbor star. Neighbor star means what? You add only the neighbor which is not marked. So I will not add A. I will add C. And in fact, if I ask you, why did I not add A? A is already visited. Do we want to go back to A via the path ABA? Will ABA that path ever be shorter than A only? Okay, no. If I will go to A via the path ABA, that will have a cost of 20, and just by standing on A, the cost is 0. So it does not make sense to revisit a node that has been visited. All right. So C will have to be visited. That is why I'm adding C to a tree. Now the most important path. AB was the old path. So the new path would be ABC. The cost till 10, cost till B was 10, and this is also 10. The cost till B was 10 and this is also 10. So the total cost will be 20. Now tell me which one, according to this picture, which one do I remove now? C or D? Which one has to be removed? Why do you remove D? Why do you remove D? D has a cost of 40, C has a cost of 20. Which one should I remove? Which one should I remove? A and B are already removed. So which one to remove? Which one to remove? C or D? A and B are not in this tree anymore. So basically, do not say ABC, say the vertex name. So C has to be removed. C has to be removed. C, ABC gets removed. Remove. Mark star. Okay, marked. Work. C, ABC. C will be visited via the path ABC at the cost of 20, which makes sense. Now, neighbors of C. How many neighbors of C do you see? How many neighbors of C do you see? How many neighbors of C do you see? How many neighbors are there? The neighbors are two. B and D. Is the B neighbor relevant anymore? Will anybody want to visit B via the path ABCB? Is that a good path? ABCB? That is a stupid path. ABCB does not make sense. So B, we need not worry about B because B is already marked. So we will worry about D. Okay. I will add D to the tree. Now, what do you think would be the path? ABC, D. The cost here is 20 and I am using CD. So 20 plus 10 is 30. Now comes a very pivotal moment in the algorithm. Srinidhi, wait. Very pivotal moment in the algorithm right now. D can be visited from two paths. And our tree actually shows that. Our tree shows that D can be visited via the path AD at the cost of 40. Or D can be visited via ABCD at the cost of 30. Do you see our algorithm has been able to detect two paths to D? Do you see? The algorithm has actually been able to detect the two paths to D. It has been able to detect the cycle. And do you also see that in this diagram right now, it is speaking aloud which path to prefer? Which path to prefer? Should we prefer the AD path or the ABCD path? Which one has the lesser distance, although it goes through many cities? Cool? Becomes clear? So we would discard or ignore this path in favor of this path. So our algorithm always removes the lesser one. Remove. Mark. Work. D. A, B, C, D. 30. And add the neighbors. The neighbors of D are A, C and E. Srinidhi, I'll come to that. A, C and E. A and C are done. So E will have to be added. E, A, B, C, D, E at the cost of 32. Okay? In case AD was shorter, of course, Srinidhi, if AD was shorter, we would have jumped that way. Alright? Of course. Because we are only removing on the basis of this value. If AD was shorter, we would have removed it via that. Cool? If CD would be 30, we will choose. Yes, Prakhar. If CD would be 30, then we would do that one. We would remove via AD. Okay. Do you guys also realize? Now, Arush, wait. What if does not work? So you'll have to stay quiet now. What if does not work? So I would actually give you a short thing, very, very small lesson also. And that lesson is not related to graph. That lesson is related to learnability. Please listen. This is actually relevant for your entire life. This is relevant for me now at the age of 36. So what is that advice on learnability that I want to give you? So what sabotages learning the most is learner not able to focus on appropriate depth. So some students and some teachers also like to say this, that you should learn everything in depth. You should learn everything at appropriate depth. Which means what? So, for example, when I am coding in Java, and I am saying x equal to 10, and this is getting stored in the computer, at that time, I will not worry about that this Java is running on my operating system, which is running on a hardware, which is actually working on transistors, which is using electrons. So while writing x equal to 10, if I will worry about the operating system, hardware, transistor and electrons, and if I would worry about the photoelectric effect and all that bullshit, maybe that quantum physics thing, I would never be able to focus on x equal to 10. Okay, so to get things done, it is necessary to focus on appropriate level of depth. Okay, so when you would learn a topic called object oriented programming, you would learn a concept called abstraction. That concept of abstraction actually means focusing on appropriate level of depth. The word abstraction means it is not necessary to know what is going below. So trust and focus, that is what abstraction means. Trust and focus, the gist of it, or focusing on appropriate level of depth, that is what it means. Okay, so this was one small rant, and I do not mean to discourage doubts, but this is about learnability. So many people have already sabotaged some learning endeavors by sometimes asking questions that would not have been relevant. Of course. Okay, so have you watched this movie called Matrix? So I'm an old guy. So in my times, it used to be a rage, Matrix. And in Matrix, there were 3 parts, Matrix 1, 2, and 3. Okay, so no problem. You don't have to say sorry. So I'm just teaching you. Okay, yeah, Keanu Reeves. So Matrix 2, in Matrix 2, there was a guy who actually betrayed the hero. And he says a very popular dialogue called ignorance is bliss. No, not trying to glamorize ignorance, but now I understand why he was saying ignorance is bliss. So I use it in a different context. Sometimes ignorance is bliss. Sometimes, because it helps you focus on what you can focus on. Okay. So if we will worry about the entire depth chain, we will not be able to focus on our task. And in fact, if you are with me, and because this random gyan that I am dishing out right now might help you in your exam also. So I would give you a trick. So see, you have to learn in phases. Phase 1, phase 2, phase 3, phase 4. With me, it has happened many times. What happens is, when I am learning, for example, this happens more with books. Let us say I am reading a book and I am on chapter 1, chapter 2, chapter 3. So there are many chapters. I am reading chapter number 1. And a particular statement comes, and that statement does not get digested in my mind. I am not able to trust that statement. So I will stop, and I would keep on daydreaming. I would keep on trying to figure out there, and then I would refuse to move forward. So this is one way of learning. Refuse to move forward when you get stuck. This, I think, is very detrimental to overall output. Now let me propose another solution. Regardless of the doubt, in phase 1, just keep on moving forward. Phase 1 is faith stage. Just trust the author. Whatever he is saying, whatever the storyteller is saying, listen to the story. First, let's listen what he is saying. Okay, that would kill 90% of the doubts. Why? Because the thing that you were stuck on is actually explained properly in chapter number 3. The storyteller has weaved his story in a way that your doubt asked here is answered there. Storytellers in their weird ways. So because you were refusing to move forward, you would have never reached that point. So phase 1 is faith stage. Listen to the story. Maybe your question is answered. Phase 2 is the questioning stage. Read it again. And now collect your questions. Do not seek answers still. So this is a revision as well as correction stage. Oh, there is a question. Just write down the question. This question. Oh, this question. Question 4. Just write down the questions. Revision is also important, and you have questions now. Okay. Phase 3. Research phase. Now is the time maybe you go back to this resource, maybe you go to ChatGPT, maybe you go to Google, maybe you go to YouTube, maybe you go to a teacher and ask your questions. If you would ask questions after faith and questioning stage, if you are trying to find answers, most likely your questions would be very smart in this stage. Phase 4, confirmation. Now you have your answers. Read it again to confirm that whatever you know, was the storyteller really saying that or something else. So I'm an old foolish guy saying old foolish things, but I think this is a trick that is very amazing. Every learner, whether he's preparing for CAT, whether he's preparing for programming, whether for JEE, IAS, whatever, this I think is a great technique of learning. So And what is our technique? What is our technique actually? So the technique that I have been using, that you might have been using, is all these phases merged together in one phase. When you are reading it for the first time, that is when you are having questions, that is when you are trying to find answers, and there is no confirmation stage. So I think that is a problem. Let's go back to our algorithm. And sorry for this long rant, but I think this was related. Try to use this trick at least for a couple of questions in your NSET exam. At least for a couple of questions. When you would be reading it. Nakul, this is very fast actually. So phase one, because you are having faith and reading it all in one go. You are not raising your questions. So that would be faster. Phase 2, you are going to skim through it to only raise your questions. Phase 3 is actually not on the resource. This is outside resource, trying to find answers. And phase 4 is confirmation stage. I don't think it is that small, that time consuming. What I'm saying is, you can move faster here also. You can skim through. This is time taking. And this is going to be super fast. Let's come back to now. Sorry for the rant. Just try this out at least in one question if you would want to, or at least one day in your life. And if this works for you, let me know. If this doesn't work for you, I am still conducting this experiment. So I'm just making a part of you as a part of my experiment. I'm trying this trick right now. These days, I'm trying this trick. All right, so let us go back and introduce you to the greatest teacher of the world. The greatest teacher of the world is repetition. So I'm sure when I would repeat this, you would learn a lot more. The greatest teacher in the world is actually repetition, and you would see the magic of repetition, and you would be able to understand a lot more in this version that I'm going to do. So tell me, what do I add in the node? What pieces of information do I add in the node, in the first node? What is the pieces of information I add here? The vertex, okay, vertex, path, and distance. Cool. Vertex, path, distance. Repetition doing its magic, you already know it now. Vertex, path, and distance. Okay, so it is AA0. Also, I think repetition would help you recall what the algorithm was. First step was remove, second step was what, third step was what, and fourth step was what. Nakul, the aim of the question is trying to find the shortest path from the starting point to all the vertices. Okay, all right, come back. Second stage is mark star. Third stage is work, and fourth stage is neighbor star. Neighbor star means the marked neighbor does not have to be added. Okay, all right. AA0. Okay, remove, mark, work. A, path is A, distance is 0. Neighbors. So who are the neighbors of A? B and D. Do you want me to change some values here? Let me change some values. Let me make it 30. So that you see that D will be explored via AD. Okay? Cool? Alright. So remove, mark, work is done. Neighbors are B and D. So I am adding B, but I am scared to add the path. The path was A, the new path is AB. The cost was 0 and this is 10, so this becomes 0 plus 10 is 10. For D it will be D, AD at the cost of 0 plus 40. Alright? Now tell me one more thing. Which one will be removed now? B or D? Which one is going to be removed? And how do we decide that? We decide that on the value. Why D? D has a value of 40. B has a value of 10. Why would you say D? So it will be B. Remove, mark, work, BAB 10. Okay, work is done. Neighbors. The neighbors are A. Of the neighbors of B are A and C. A does not have to be added. C will be added. C, ABC at the cost of 20. 10 plus this 10 is 20. AB plus this C is ABC. Now which one will be removed? C or D? C or D? C or D? Of course C. Why are you saying? Who said D? Why D? D is at 40. C is the distance of 20 from A. From A, the distance of C is 20. The distance of D is 40. So C will be removed. Remove. Mark. Work. Add neighbors. The neighbors of C are B and D. But B is marked. So D will be added. Now help me add D at appropriate cost according to this diagram. D is added again. ABC is the old path. The new path is ABCD. The old cost is 20 and this is 30. So D has been discovered at the cost of 40. So do you see our algorithm has been able to detect D from two paths? It is able to detect D at the cost of 40 here and at the cost of 50 from that path. And the algorithm has been able to detect both. We always remove the shorter one. Which one will I remove now? D will be explored via ABCD or AD. Which one will be preferred now? AD. Are you guys aligned with me? Did you understand how smart the algorithm is? The algorithm actually is now going to reject ABCD path and select AD path. Remove, mark, work. So D preferred the path AD. But after having explored the ABCD path, AD path was preferred only after exploring ABCD. And we got to know that this was 50. We rejected it. Remove, mark, work, neighbors. Neighbors of D are A, C and E. A and C will be ignored. They are already marked. They are already visited. So E. E via the path ADE at the cost of 42. Okay. Now tell me D and E. Which one will be used? D is still in the tree. But it is of no consequence now. No problem. So E is removed. Remove. Mark. Mark. Work. E explored ADE 42. Neighbors. Neighbors of E are D, F and G. D is marked. So F and G. If you are with me and if you are actually working, the paths I will write ADEF, ADEG. What I want from your side. What's the cost here? 42 plus what? What is the cost here? For F, 45. And what is the cost for ADEG? What's the cost there? 42 so far. Using this 8, 50. 50. Alright. Now which one will be removed of these three? Which one will be removed of these three? F. Remove. Mark. Work. F, A, D, E, F at the cost of 45. Neighbors. Neighbors of F are E and G. E is marked. G is not marked. G is not marked. Okay. So G has a new path. That is A, D, E, F, G path. 45 plus this 3, 48. Out of these three now, which one will be removed? G had 48. So see, I have two paths till G here. Two paths. ADEFG, ADEG. Do you see the algorithm has preferred? So there was one path ADEG. There was another path ADEFG. Both paths are here ADEFG, ADEG. Do you see one of the paths has been preferred to other? Now I will use this path. Remove, mark, work, ADEFG at the cost of 48 and add neighbors. Now G has no unmarked neighbors, so nothing would be added. The algorithm would keep on working. The next thing that it can remove is either D or G. Remove, mark star. Mark star means if you remove something that is already marked, nothing to do. So mark it as star actually, if you remember. So if you remove something that is already marked, you have nothing to do. G would be removed again. So there is another path of G. So removed, but G is already marked, so nothing to do. This is our table. This is the output. The output that you have to give to the person who has asked the question is this. That from A, these are the shortest paths. Is the algorithm clear to everyone? Is the algorithm clear? Did you enjoy it? should I give you a question, a graph with some values, and you will be requested to share this output with me? You will have to share this output with me. Will you be able to do that? Kunal, this is the final answer. This table is the final answer, beta. This table is the final answer. This table is the final answer. Now we know from A, these are the shortest path to each of the vertices. This table is the answer. Okay? Root is not the answer. So, root to every vertex is the answer. The table is the answer, basically. How will we share the answer? So, you'll have to write a longish line. Okay? Is this scalable to bigger scale? Because at this scale, we can just simply tell the answer. Ah, no. So, no, I would make it difficult enough. Don't worry. In exam, one word. So, in exams, actually, there can be A, B, C, D. No, A, B, C, D. And you can be, you might have to choose one of those. So, the question could be, what is the shortest path from A to G? A to G. And so, there would be options A, B, C, D. Okay, or it can be asked which one of them is, if it is descriptive, in that case you can be asked shortest path to one of the vertices. Okay, not the entire, one of the vertices can be asked. No, will we write path A, B, C, D, E, F, G? Of course, of course. So that is fine. Actually, you can write A, B, C, D, E, F, G. Okay, so now let me share a question with you. So let me connect it like that. Okay, like this. This is the graph. B, C, D, E, F. Okay. 5, 5, 10, 20. No, no, not 20. So let this be 30. 30. 2, 6, 3, 8. Over to you. So over to you. Starting point in this case is not A. I am giving you a starting point of C. C. Okay. So just tell me the shortest path from C to actually everyone. So it can be framed like whatever, but I want the shortest path to everyone. Over to you. The question is over to you. I will hide my face so that you can focus on the question and not me. I want that table that I've just taught you. I want the table from you. All right, let's solve this together. Let's solve this together. I do not know the answer. I just invented the question in front of you. So, Aman, let's do it together, beta. Let's do it together, no? Okay. So just pay attention. I'll do it quickly. So C0 is where we start. I hope everyone knew that the starting point was C. I hope you focused on that. C0 is my starting point. Okay. Remove, mark, work. So C0. Neighbors are B, D and E. Okay, B, BC at the cost of 5, D, CD at the cost of 10, and E, CE at the cost of 2. Which one do I remove now? Which one do I remove now? If I have your attention, which one do I remove now? E. Remove, mark, work, add neighbors. Neighbors are C, D and F. Of course, C will not be done, but D and F can be added. D at the cost of CED, 2 plus 6, 8. And F, CEF at the cost of 2 plus 3, 5. Did you guys also detect two paths to D? Two paths to D. CD at the 10 and CED at the cost of 8. Did you guys also do that? Cool, great. So the algorithm is working. Nice. Which one to remove now? Which one to remove now? B, D or F? Which one to remove? We can remove B or F. Both are equal actually. Both are 5. So we can remove either one of them and the result would remain same. Remove, mark, work, F, C, E, F at the cost of 5. Neighbors of F are E and D. E is done. So D will be explored again. Another path to D, C, E, F, D at the cost of 5 plus 8, 13. Did you guys detect 3 paths to D or not? Did you guys detect 3 paths to D or not? So there are 3 paths to D. One is CD, another is CED, another is CEFD. Okay. But which one will be removed next? In these 4 values, which one will be removed next? Actually, B will be removed. No. B is also there, no? So B will be removed. B will be removed. 13, why? Right now, B, BC is the smallest value, no? So that is going to be removed. The next vertex to be discovered is B actually. So D will not be explored. D will not be explored yet. B, B, C, F. Actually, there is one more path. That might be smaller. You don't know. Okay, so B, B, C, 5 comes out. Remove. Mark. Work is done. Remove. Mark. Work is done. Add neighbors. So the neighbor is A. C is done. A is B, C, A at the cost of 5 plus 5, 10. The next to be removed now is D. Now is when D will remove because that is at the cost of 8. D. Remove. Mark. Work. D at the cost of CED at 8. Neighbors. Neighbors of D are only unmarked. Neighbor are D, C, E, F and A. But the only unmarked neighbor is A. So I will use A. A, C, E, D, A. 8 plus 30 is 38. So the next removal now is A and D are actually competing. So let me remove D. But this is already marked now. So nothing to do. Remove and nothing to do. Remove mark star. Mark star was if you remove something that is already marked, don't do anything. Okay, nothing to do. Now A will be removed. A, remove, mark, work. A, B, C, A, 10. Add neighbors. There are no neighbors to be added. Okay. The next one to be removed is D, but nothing now. Remove mark star. A, remove mark star, already marked. This is the table. Did anyone get this table? So the final answer is this table. Everyone has been asking what is the final answer. The final answer is this table actually. There is no other answer. The table answer is this table. Answer is this table. So the answer that you had to written was this table. Okay. How many of you got the same answer? How many of you got the same answer as me? Did anyone get this? Arush got this. Did anyone get this? Are Kunal, don't worry, no. So let us say this is the answer and let us say they are A, B, C, D. A, B, C, D. And this is told to you Which one of these is true? Which one of these is true? The path to F is CEF at cost of 5. Cost of 5. Path to B is BAC at cost of 80. Which one of these is true? This question can be asked like that, no? If it is descriptive, so in descriptive you can write this entire table. We have to concatenate the days. Okay. Even in objective, let me present this question as a fill in the blank. Path to A is fill in the blank at cost of fill in the blank. Okay. I hope if you have solved the table, now you can give this answer. Okay. Summary counting, no, we are not doing anything anymore. I think I am done with the stuff that I wanted to teach you. So 7 questions I had in mind. I knew that I would be able to do 4, but I think that is fine enough. No problem. Okay. All right. Summarize the lecture. So the summary is that we did actually 4 questions. In fact, help me recall the questions. Do you recall the first question? Path of A should be CBA. Yeah, that is CBA actually, not BCA. Cool. So few paths went haywire. So this is actually entirely CB. This is CBA. All right. So what I am asking is, help me recall the lecture. Do you remember the first question? 1997 question. I told you that P plus Q equal to 1997. P plus Q is 1997 and both are prime. So what is the product of these two numbers? So one thing was explicit, that both are prime. One thing was hidden, that one of them has to be, because the sum is odd, so one of them has to be odd and one of them has to be even. So the only even prime number is 2. Do you remember the trick? So sometimes the things that would be shown to you would not be obvious. So here one thing was obvious, that P and Q are prime. The unobvious thing was that because their sum is 1999 and that sum is odd, so one of them has to be odd and one of them has to be even, and the only even prime number is 2. So that was a hidden thing. Okay. The second question that we did was that xy plus yz question, again on odd and even. Do you remember that question? Where we figured out that xy raised per y raised per x and I think y raised per z and z raised per x is actually even. So that was true, false. The third question that we did was bottles and poison, bottles and rats. Do you recall that question? What that question was? That do not label the bottles in decimal number system. Label the bottles in binary number system and assign one rat to a single place in the binary. Based upon which rat lives, which rat dies, you can decide which bottle has the poison. Then we did the extra algorithm. Alright. So I wish you guys best of luck. And meanwhile, I had a longish rant on learnability. I'll share the notes, don't worry. So if you do not take anything else from whatever I have taught you, I would request you to let me share the notes. I would request you to use the advice that I have given to you in the advice that was related to abstraction, that you should not try to learn at depth, you should try to learn at appropriate level of depth or appropriate level of abstraction. Okay, and maybe you can use my phased way of learning. So actually no, when I would say that you should use that phased style of learning, you would not really trust me. So I would recommend you go to Google and learn about this guy called Richard Feynman, and he had a technique called Feynman learning technique. So this guy was a superstar scientist, and at the heart he was pretty basic like me and you. So this is a story of a person who was an ordinary man, but because he had such superior learning skills, he became extraordinary. So an ordinary man, using superior learning skills to become extraordinary. That is what Feynman is about. So that is what I am saying. Google about him, learn Feynman technique, and see whether that works for you or not. We should be asked this. Calculus would not be asked. Calculus is not one of the topics. Calculus is not one of the topics. Okay. Let me first share the notes. After that, we will talk about anything else. गुजरने वाली हवा मेरा इतना all right, so check out the notes. Can you check out the notes? Can you check out the notes? Suraj, don't worry, I'll share everything. Okay, cool. So the different type of resources that I have to share for number system. For number system, let me go to Hacker Earth. Hacker Earth. Model arithmetic. So I told you in number system, the most key thing that you should learn is modular arithmetic. Modular arithmetic, because the question setter might have a few questions on modular arithmetic. Here's the link for that. Don't worry, I have shared the link. Okay, let me also share the entire screen. So this is the first resource regarding number system. The second resource was regarding recursion. So for that I went to YouTube, I went to Pepcoding recursion playlist. Recursion playlist. There is no playlist for recursion as such. On the home there is actually. So recursion and backtracking. This playlist, if you want to learn all of it, it would actually help you.
Hi guys.
Okay, but I would recommend do not learn any further than 45. From floodfill, 2 difficult question starts. So the last question you should learn is 45. If you have lesser time and you do not want to watch all the videos from 1 to 45, then I would say only watch videos from 36 to 41. 36 to 41. Start watching from start watching from 36 and watch till 41. Okay. So this is about recursion. For recursion, is it clear which resource to watch? For recursion, is it clear which resource to watch? 36 to 41. If you want to cover more, if you would watch from 1 to 41, you would do yourself a favor. You would have better chances, but 36 to 41 would be sufficient also. Actually, why learning from 1 to 41 might be a smarter idea is because you would see how I have built the story. So that might help. For permutation and combination, what I say is actually the questions of permutation questions are going to be dynamic programming questions. Let me say it again. The permutation questions, the permutation and combination questions are not going to be B and C questions. They are going to be dynamic programming questions, because the person who had set the exam is actually a programmer also and a mathematician also. So he knows permutation combinations and he knows dynamic programming. So what I am trying to reverse engineer his thought process. The questions that he's encountering these days about permutation combinations are actually dynamic programming questions. So it is highly likely that they are going to be dynamic programming questions. For that, what to do? Another playlist. Playlist in level 1 called dynamic programming. Not level 2. Level 2 is too hard. So level 1, dynamic programming level 1. Is there a playlist? Yes, there is a playlist. So here is the playlist. Okay.
Ladies and gentlemen.
Ruko. So here, of course, you should not watch all the 36 questions. No sense in that. So from the first 20, if you watch one and skip one, from the first 20, if you watch the 10 of them, that would help you a lot. So this is about dynamic programming or permutation and combinations. Okay. All right. I think that much should be enough. Hacker Earth is coding in it, but the article that I've given to you, you just have to read that article. For graph question, you don't have to code. For graph question, one is enough. So I've done the important algorithm to set a context. That much is enough. DP does. So what I'm saying is, even those questions that you would be reading, do not watch the part from where I start coding. Watch the part before the coding. If you would watch the part before the coding, you would see the discussion about permutation and combinations, and you would not have to worry about the coding part. Stop where I start coding. Okay? No, differentiation and integration is not a part of the syllabus. I checked the syllabus just before starting. It is not a part of the syllabus. Calculus is not a part of the syllabus unless the syllabus has been changed again. Okay? We need to learn about time complexity. No, you don't. Please share lecture learnability lecture 1 link. As soon as that can be shared by Saloni, I have already forwarded the request to Saloni. So she will be sharing. Okay. For DP, these videos, Srindhi, these videos. This is the link. These videos here. From the first 20 videos, select any 10 and watch the part before coding. Watch the part before coding. Okay. All right. See you guys. I don't know when. Hopefully you would get selected, and hopefully I would be called there to teach, and I would love to teach you guys in class someday. Okay. For recordings, I have already shared the request with Saloni, and she would teach you. She would send the recordings. Don't worry. Okay. Would love to see you guys in SST on WhatsApp. You can have my number if you want. So this is the phone number. I don't know actually if I'm allowed to share the phone number or not. So send me a request on LinkedIn if you want. Okay. All right. See you. Bye bye. Good night.